Alright, we are going to talk about solutions. Many of you were in class when we covered these notes. This video is just to go back over for if you want to review, or if you missed the day and need to take the notes. These notes are along in your packet. We'll go fairly quickly over them, so you might need to pause to have time to write down to fill in the blanks. Alright, solutions. So first of all, what are solutions? Alright, this is a term, or solutions is something we covered actually first semester. Remember, it's a homogeneous mixture. It means it is a mixture of compounds or elements, and when you look everywhere in your sample, it is a uniform mixture, meaning even throughout. Alright, it's even throughout. So if you had a container of salt water, so this is salt water, okay? So this is my container of salt water. What's it have in it? Alright, well, salt water is traditionally sodium chloride and water. So no matter where you looked in here, top, middle, or bottom of these little dots with my sodium chloride ions, no matter where you looked, if I took a sample here, or here, or here, you would get the same amounts of sodium chloride and water, a uniform mixture. No matter where you look, you get the same stuff. If you remember, there's something called a heterogeneous mixture first semester, which is not uniform. This would be like pizza, alright? If you take a sample off the top of pizza, you might get cheese or pepperoni. If you take it in the middle, right, you might get sauce. If you take it on the bottom, you might get crust. So it's a mixture of stuff, but it's not even throughout, meaning wherever you take the sample from, you might get something different. Alright, you can have solid, liquid, and gas samples of a solution. Steel is a mixture of iron and carbon. Well, the ocean, we'll just say we're talking about salt water here, so water and sodium chloride. Air, I mean, you got carbon dioxide, you got oxygen, you got nitrogen gas, you got all kinds of stuff in the air. Alright, there are two parts of a solution, the solute and the solvent. Alright, these are definitely two words that you need to know, solute and solvent for vocabulary. Solute is what is being dissolved, and solute is a dissolving medium, or another way to say it is what's doing the dissolving. Once again, we'll go back to our salt water container, and let's see. Let's change my color here. So I've got water in here, which is my nice blue color. So here's my water. Okay, so H2O. Alright, when you place salt into water, what happens is the salt dissolves, right? So the sodium chloride might be a big chunk at first, but all of a sudden gets smaller and it dissolve it all in the water. Well, the sodium chloride is the solute. It's what's being dissolved. And the water is the solvent. It's what does the dissolving. And this is a term you definitely need to know. Water is called the universal solvent. Water dissolves most things. We'll talk about why in a few minutes. Alright, more vocab. There's a lot of it this chapter. You're going to want to probably make some flashcards and practice. Alright, first two terms. Soluble and insoluble. Okay, soluble is a substance that will dissolve in a solution. So sodium chloride, NaCl, is soluble in water. Alright, soluble means it will dissolve. So sodium chloride, if you put in water, will dissolve. Something else that's soluble in water? Sugar. Okay, sugar is soluble in water. Insoluble is a substance that, when you put it in it, usually refers to as solid substances, will not dissolve in water. For instance, plastic is insoluble in water. Alright? Meaning it will not dissolve. Now the term immiscible and miscible are usually used for two liquids. Alright, immiscible is pretty easy. What two liquids don't mix? Well, so oil is immiscible in water. Right? If you put oil in water, they won't mix. Two liquids that are miscible. Well, hydrogen peroxide is H2O2. Hydrogen peroxide is miscible in water. Alright, so it will dissolve in water. Okay, so our four terms here, soluble and insoluble, usually referring to as solids or gases. Alright, and to a solvent. Immiscible and miscible are usually referred to as liquids. Right? Immiscible can't dissolve in each other. Miscible can. Alright, solvation, the process of surrounding solute particles with solvent particles. Alright, when we say something's dissolving, here's really what's happening. So, what happens is you might have a block of salt. If we zoomed in on that, we would see that we'd have sodium and chlorides, a bunch of them sticking together because they're ionic compounds. So we just have a bunch of these sticking together. Solvation is the process at which if you put salt into water, alright, the water particles come and surround the sodium chloride. Alright? And what they'll start doing is they'll start breaking these apart, meaning these water particles will start coming around. I'm just going to put it as circles, okay? And they start taking away some of these sodiums and some of these chlorides. Well, when you start to do this, alright, these pieces start to get smaller and smaller, and eventually you don't even see it anymore. Okay, so the sodium chloride is starting to dissolve because water comes in, starts surrounding these particles, and starts removing, alright, the sodiums and the chlorides. Alright, and in class there was a video we showed with this, and if you missed class, there's a video that I can show you. It'll take like 1 minute to help you understand solvation. Alright, the general rule, like dissolves like. How do we know if something's going to dissolve? Well, this term like dissolve like helps us. Polar will dissolve polar. Nonpolar will dissolve nonpolar. Organic dissolves organic. Let me talk about what I mean by that. First of all, polarity. We're going to first have to identify whether something is polar or something is nonpolar. Okay, we're going to figure out whether something's polar or nonpolar. How do we do that? Well, first of all, polar means you have regions of opposite charges. For the purposes of this class, we're going to consider ionic compounds to be polar. Right, if you remember back in first semester, an ionic compound is a metal and a nonmetal together. So if you looked on your periodic tables, remember your metals are to the left of the staircase, your nonmetals are to the right. Alright? So identify something as ionic, we're going to consider it as polar. Why? Because remember, ionic compounds have a positive and negative ions that are put together. Alright, for the purpose of this class, something that's nonpolar, alright, it's going to be covalent compounds. We'll consider covalent compounds nonpolar. There's an exception though, you definitely have to know this. Water. Water is the exception. Alright, water is covalent. It's H2O, right? These are two nonmetals. But it is polar. Alright, water is polar. And with that being said, this is actually why water is a universal solvent. Because not only is it polar, but it's covalent. Alright, just a second ago I said like dissolves like. So if we put something polar into water, it will dissolve. Because like dissolves like. Polar will dissolve polar. So all these ionic compounds we've been talking about, for the most part, they'll dissolve in water. But since water's covalent, there's a number of covalent compounds, even if they're not polar, that will dissolve in water as well. This makes water the universal solvent, because it'll dissolve ionic and it'll dissolve covalent. Alright, let's look at these and figure out why. So if I want to figure out if things are going to dissolve in one another, the first thing I need to do is look at my solute. What am I going to put into my solvent? Okay, remember the solute is what's being dissolved, the solvent's what's doing the dissolving. NaCl. Well, Na is a metal, Cl, chlorine's a nonmetal. This makes it ionic, and if it's ionic, we're going to consider it polar. KBr. Potassium's a metal, bromine's a nonmetal. That means it's ionic, we're going to consider it polar. CH4. Carbon and hydrogen are both nonmetals. This makes it covalent, so we're going to call it nonpolar. So with this rule that like dissolves like, polar solvents will dissolve polar solutes. Nonpolar solvents will dissolve nonpolar solutes. So polar will not dissolve nonpolar. Now let's break it down even further. So if I want to dissolve sodium chloride, we figured out that sodium chloride is ionic. Alright, which means it's a polar solute. So how am I going to dissolve sodium chloride? Well, I've got to put it in a polar solvent. So water. So if we put sodium chloride into water, it will dissolve. KBr is ionic, which also means it's polar. So if I put it into water, it'll also dissolve. Like dissolves like. CH4 is covalent, which means it's a non-polar substance. Alright? So, some non-polar substance, there's this thing called acetone. Acetone is non-polar. So if I put CH4, which is methane gas, if I dissolve it into acetone, alright, it will dissolve because it is non-polar. Non-polar dissolves non-polar. With all that being said, one more thing for this video. Factors affect the rate of solvation. If I want something to dissolve faster, there's three things I can do. First thing I can do is agitate the mixture. This means stir it. Okay? If you ever made Kool-Aid at home and you want to dissolve it, if you just dump the Kool-Aid into water and just let it sit there, it's going to take a while. But usually you stir it up. Alright? Mixing it all up. If you agitate it, it will dissolve faster. Increase the surface area. If I have a big old chunk of sugar or a big old chunk of Kool-Aid, you might have had this before happen to you, that falls out. What we want to do is we want to break this up. Alright? Increasing the surface area means breaking this up. So we're going to crush this into tiny little pieces. And if you crush it into tiny little pieces, you've increased the surface area. Surface area is here. If I put this into water, only the outside will start to dissolve because this inside is not touching the water. But if I crush it up, all the stuff on the inside is now all on the outside now, and now all of this is touching the water and can dissolve. And then increase the temperature. Okay, if you increase the temperature, you can make your solute dissolve faster. Okay, so if I just, you can actually do this at home if you want to increase. Well, you can do sweet tea this way. All right, when you make sweet tea, you want to boil the water because it will dissolve the tea faster in it. There's another reason for it, and we'll talk about it on the next video. Alright, so that's the video for Introduction to Solutions. So if you missed the notes, make sure you grab those as you went along. I did a couple of demonstrations in class and videos with this. So if you missed, you might want to ask me to do those, and I can show you to help understand some of these processes.